Today we are going to continue to solve degree 2 quadratic equations. So you guys took a quiz on the solving, right? So we're still going to continue solving a degree 2 quadratic equation. We just learned how to do it by factoring. The next way I'm going to teach you how to solve a quadratic equation is by using square roots and the quadratic formula. Remember, factoring isn't the only way to solve a quadratic equation. In fact, some quadratic equations can't be solved by factoring. So we have to have different methods to use so that we can still solve the equation. So the other methods you learn are square roots and the quadratic formula. But there's a big problem. If I'm going to teach you how to solve a quadratic equation using square roots or the quadratic formula, you have to know how to simplify a square root. Now, this is normally something that you have seen in geometry and algebra 1, but normally it's very brief. So sometimes you're very rusty at it. Some students don't remember it at all. So a lot of times it's better for me to review how to simplify a square root before you see it in the solving, so it doesn't kind of blow your mind. All right. So today we are going to review how to simplify a square root. Then we'll get back to the solving of the quadratic equations tomorrow. So today we're going to take a brief pause and simplify square roots just to kind of refresh your memory because you are going to see it tomorrow. All right, let me get my notes up and then we will go. Okay. So guys, when it comes to square roots are the opposite or the inverse of squaring something. If you want to unsquare something, you use a square root. So when you take the square root of a number, you are basically being asked, what number did you square to get that number? All right. And we have numbers that we call perfect squares in this world. 1 squared, 1 times 1 is 1. 2 squared, 2 times 2 is 4. 3 squared, 3 times 3 is 9. 4 squared, 4 times 4 is 16. All of these numbers that I have listed, and the list goes on, it goes on forever. These are all what we call perfect squares. These are numbers that you can unsquare and get a whole number back. If I was to take the square root of 25, that's basically asking you what number did you square to get 25? The answer is 5. So these are numbers that when you take the square root of them, you get a whole number answer back. But then there are so many numbers in this world that when you take the square root of them, you don't get a whole number back. So guys, what if I asked you to take the square root of 12? What number can you times by itself 2 times to get 12? Well, if you notice, 12 ain't on this list because 12 is not a perfect square. If you tried to take the square root of 12 and unsquare it, you would find out the answer is a decimal. It's 3 point something, 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 something. And it's not just a decimal, it's a really ugly decimal. It's an irrational number. It is a decimal that never ends and never repeats. So every time you take the square root of a number that is not a perfect square, you get an irrational number, which is a really ugly number to work with in math. So a lot of times we don't want you to take the square root of 12 then, because I don't want this really ugly decimal that you're going to have to round. And we don't want to round because the minute you round, you lose accuracy. It won't make the equation true anymore if you round your answer. So we don't want you to round. So what we have you do with all of these square roots that you can't take the square root of and get a whole number back, we just have you simplify the square root. Kind of like you simplify a fraction in your final answer, you're going to simplify all of your square roots as well. So I want to go over with you how do you simplify a square root. So in order to simplify a square root, you have to know these two properties. These are two things that you're allowed to do with square roots. If you have the square root of a times b all under one square root attached by multiplication, you're allowed to split that into two separate square roots. I'm allowed to split that into the square root of a times the square root of b. That's an okay thing to do in math, and it doesn't change the answer. So we're going to use the fact that we're allowed to do this when we go to simplify square roots. Another property of square roots, another thing you're allowed to do with them, is if you have the square root of a fraction, the square root of a divided by b, you're allowed to split that into individual square roots as well. You're allowed to rewrite that as the square root of a divided by the square root of b. You can split them into their own individual square roots, and it doesn't change the answer. So that's another thing we're going to use to simplify square roots, okay? All right, so let's do it. So first of all, don't be fooled. On your homework tonight, if they ask you to simplify square roots, they can still throw a number like this at you. Simplify the square root of 49. Well, I hope that you guys recognize that the square root of 49 is a perfect square. So when you unsquare it, What number did you square to get 49? The answer is 7. So some of the answers are going to be nice on your homework, but some of them are not going to be nice. Let's say this. I talked about the square root of 12. What if I asked you to take the square root of 12? Well, guys, if you did this, if you asked your calculator, what is the square root of 12? It's going to tell you a really ugly decimal. See that? 3.464. And guys, truthfully, it goes on forever. It doesn't end there. It's just where your calculator stops. This is an irrational number. It is a decimal that goes on forever and ever and ever and never repeats. It's really ugly. So we don't want you to round it, because if you rounded it, let's say to 3.5, if you tried plugging 3.5 back into an equation that used the square root of 12, you've rounded the answer. It won't make the equation true. The only thing that will make that equation true is the square root of 12 or a simplified version of it. So we don't want to give the decimal. We want to give the simplified answer. So this is how I teach you to simplify square roots. If we want to simplify the square root of 12, then you want to go to your list of perfect squares. Go to the numbers that you can take a square root of and get a whole number, and find the biggest one on this list that divides evenly into 12. So guys, what's the biggest number on this list that divides evenly into 12? A good way to do this is go to the biggest perfect square close to 12 without going over. So that would be 9. And just start dividing 12 by these numbers. Does 12 divide by 9? No. So it's not 9. Does 12 divide by 4? Yeah, it does. So 4 is the biggest perfect square that divides evenly into 12. So we're going to break him up into the square root of 4 times the square root of, 4 times what gets me 12? 3. We're splitting him into 2 separate square roots that multiply to equal him, because we're allowed to do it. It won't change the answer. All right, now what we've done is we've pulled a number out that we can take the square root of. So now what is the square root of 4? It's 2. And it doesn't have a square root anymore because we've taken the square root of 4 to get 2. So now the square root of 3, no perfect squares on this list besides 1. We don't count 1 because he doesn't change the number. No numbers on this list divide evenly into 3. So that means the square root of 3 is a simplified radical. So the simplified answer for the square root of 12 is 2 times the square root of 3. That's the simplified version of the square root of 12. All right, can I get a thumbs up if you guys remember simplifying square roots? Do you guys remember doing this? Now, okay, some teachers in geometry and algebra 1, they teach you to simplify it like this. So I'm going to show you it just in case it rings any bells, but it's not the way I like to teach it. Some teachers will tell you to do this. Instead of telling you to find the biggest perfect square that divides evenly into 12, they tell you to break 12 up into any factors you want, any numbers that multiply to 12. So maybe you were thinking, all right, the square root of 6 times the square root of 2. The problem is you've broken it up into 2 numbers that you cannot take the square root of. These are not numbers on this list. Okay, that's fine. Keep going. Keep breaking these factors down. You're making like a factor tree until you get all prime numbers. So now we're going to break down the square root of 6 into the square root of 3 times the square root of 2. And then I still have this square root of 2. So now if you notice, all of the numbers under the square root are prime numbers. They can't be factored into other numbers that multiply to equal them anymore. So what you do is you take all of your matching square roots, like the square root of 2 times the square root of 2. Well, guys, the square root of 2 times the square root of 2 is the square root of 4 if you put it back together. And what's the square root of 4? It's 2. So I'm left with a 2 times the square root of 3 is what's left. So you still get the same answer by making this factor tree if you want, and then every 2 square roots will cancel out to a whole number. But I don't like doing that. To me, it just takes way too much time. I would much rather find the biggest perfect square that divides evenly into this number and break it down one time. But I know this is how some geometry and algebra 1 teachers teach it, so I wanted to show you it in case that rings a bell. But this is how I'm going to teach you to do it. Just in case anybody wanted to see the other way, you do what you got to do. All right? All right, let's go to the next one. Let's say I asked you guys to simplify the square root of 45. All right? You're being asked, what number can you times by itself 2 times to get 45? Well, guys, you can't. 6 times 6 is 36. 7 times 7 is 49. I've skipped over 45. That means the square root of 45 is a decimal in between 6 and 7. So it's 6 point something. Well, we don't want to round our answer. We're just going to simplify our answer. So you have to find the biggest number on this list that divides evenly into 45. So let's start with 36, the closest one to it without going over. Does 45 divide by 36? No. Does 45 divide by 25? No. Does 45 divide by 16? No. Does 45 divide by 9? Yep, 9's our guy. 9 is the biggest perfect square that divides evenly into 45. So we're going to break 45 up into the square root of 9 times the square root of, well, what's left over? 9 times what gets you to 45? 5. So now take the square root of the number that you can. What is the square root of 9? It's 3. And he's not under a square root anymore because he's just 3. The square root of 9 is just 3. Now the square root of 5, guys, I can't take the square root of 5. 5's not a perfect square. And none of these numbers, again, 1 doesn't count, divide evenly into 5, which means 5 is a simplified radical. So we leave him as the square root of 5. So your simplified answer is 3 times the square root of 5. Is everybody okay? Am I making sense? Everybody good? So again, it's just like reducing a fraction. You're just reducing a square root by getting perfect squares out of it. All right, let's try another one. How about the square root of 32? If I have to simplify the square root of 32, well, guys, 32 is somewhere in between 25 and 36, right? So he's some decimal in between 5 and 6. He's 5 point something. But I don't want a decimal. I want a simplified square root. So what's the biggest number on this list that divides evenly into 32? Well, then, guys, I would start with 25 and work my way down the list. By doing this, you'll always find the biggest one first that works. 32 doesn't divide by 25. Does 32 divide by 16? Yeah, it does. 16 is our perfect square. So we're going to break this up into the square root of 16 times the square root of, well, 16 times 2 gets me 32. Now, take away the square root that you can. What is the square root of 16? What number did you square to get 16? 4. No more square root. Now, everybody wants to think the square root of 2 is 1. But guys, when you square root a number, you're not cutting it in half. You're literally saying what number can you times by itself 2 times to get 2. There's no number or whole number that I could square to get 2. So that means he's a decimal, and there's no numbers on this list that divide evenly into 2. Again, 1 doesn't count. So he is a simplified square root. And your answer is 4 root 2. Okay? All right, you guys try this one. Simplify the square root of 75. Go to that list. Now, guys, this list goes on and on forever. I don't think I'm ever going to give you a number where you would need a number bigger than 225, but just know this list goes on forever. These are not the only perfect squares that you could be testing or using. All right? So what's the biggest number on that list that divides evenly into 75? All right, hopefully you recognize that it is the square root of 25. 25 is the biggest perfect square that divides evenly into 75. And then the square root of 25 times 3 gets me 75. So now take away the square root that you can. The square root of 25 is 5. And then the square root of 3, I can't take the square root of 3 and get a whole number. And there's no numbers on this list, 1 doesn't count, that divide evenly into 3. So we just leave him as the reduced square root of 3. Okay, thumbs up if you feel okay. Everybody all right? Everybody's good? Again, not bad, not a lot of work. So again, I think this takes more work. If you just find the biggest perfect square, it doesn't take as many steps. All right. Also, just be on the lookout for this. Every now and again, they'll throw this at you. Simplify the square root of 10. So again, a lot of people look at 10 like, oh yeah, 5, half of 10. But remember, that's not what a square root is doing. A square root is asking what number can you square to get 10? Like 2 times 2, or 3 times 3, or 4 times 4, or 5 times 5. Nothing squared gets me 10. So 10 is not a perfect square. So you would go to your list. What's the biggest number on this list that divides evenly into 10? Again, don't count 1. Well, guys, no numbers on this list divide evenly into 10. So that just means that the square root of 10 is already a simplified radical. It's kind of like, when you get a fraction like 2/5, it's already reduced. You don't have to reduce it anymore. That's the same thing. The square root of 10 is already a simplified square root. You just leave him as the square root of 10. And then some students, they'll get confused if I asked you to simplify the square root of, let's say, 77. They're like, oh, it's a pretty big number. There must be a number that divides evenly into them, right? No, guys, the square root of 77, there are no numbers on this list that divide evenly into 77. So that means the square root of 77 is also an already simplified square root. There's nothing you can do to it to simplify that. So even if it's a big number, it can still be an already simplified square root, okay? All right, is everybody okay? Thumbs up. You guys are hanging in there? All right, perfect. All right, the only other thing I want to show you, and guys, I'm not going to lie, this is definitely the more annoying part. The fractions. When you take the square root of fraction, what do we have to do? This is definitely a little bit harder and a little bit more annoying. So hang on. Let me show you what happens with these ones. All right. What number am I on? I am on number 7, I think. Okay. Okay. Let's say you were asked to take the square root of 3/5, because guys, sometimes when you're solving these quadratic equations using the square roots or the quadratic formula, sometimes it's going to be a fraction. You have to know how to handle the square root of a fraction. So normally I would look at this like, okay, 3/5. Look at the fraction itself. It's an already simplified fraction. I can't reduce 3/5 any more than it already is, and I'm taking the square root of it. I would look at this like, it's simplified, right? There's nothing I can do. I can't take the square root of any of these numbers. 3/5 can't be reduced. It's a done deal. Technically, you're right. That is a done problem. The problem is math has all these little rules that make everything more complicated. So if I take this square root and I split it into individual square roots, make it the square root of 3 divided by the square root of 5, right? We're allowed to take one square root and break it up into 2 individual square roots. And again, I would say, well, again, nothing I can do. I can't take the square root of 3, and he's already a simplified radical. I can't take the square root of 5, and he's already simplified. So this problem is done. Again, you are right. This is a done problem. The problem is math has a rule where we don't like to divide by irrational numbers. Every time you take the square root of a number who is not a square, the answer to that question is an irrational number, which is a number that is a very long, ugly decimal that doesn't end and doesn't repeat. So math says that it is irrational to divide by an irrational number. So we're technically just going to clean up the answer. We're going to fix our answer so that it abides by the rules of our math class. All right, so what you're going to do is basically math says it's not okay to divide by the square root of 5. So we have to get the square root of 5 out of our denominator. It's okay to have square roots in the top, the numerator, but it's not okay to have square roots in our final answer in the bottom. So to get rid of the square root of 5 in our bottom, you're going to take him and you're going to times him by himself, the square root of 5. And then whatever you times the bottom of a fraction by, you have to times the top of it by that too. So I have to times the top and bottom by the square root of 5. And then watch what happens when you do this. By timing the bottom by himself, I'm basically creating a perfect square, guys. I'm timesing something by itself twice. The square root of 5 times the square root of 5 is the square root of 5 times 5, 25. And what is the square root of 25? It's 5. So on bottom, I have 5 because I've created a perfect square. By multiplying the bottom by himself, I've created a perfect square. Now I can take the square root of that number, and it's just 5. On top, all you have to do is multiply the radicals back together. The square root of 3 times the square root of 5, I'm allowed to multiply the numbers back together and make them one square root. So that's going to be 1 square root of 3 times 5, 15. So now you end up with the square root of 15 divided by 5. Now some students are like, oh, well, 15 divided by 5. Oh my God, no. 15 is stuck under a square root, so you can't get to him. 5 is no longer under a square root, so they have nothing to do with each other anymore. You cannot use them together because one is under a square root and one is not, all right? So now the only thing you should check is make sure that the square root of 15 is a simplified square root. do any perfect squares divide evenly into 15 that I could reduce him with? And luckily, no. So this is a simplified answer. So a lot of times when you take the square root of a fraction, it's not like this isn't okay. It's just you have to fix the answer to say something better. Okay? All right, let's try that again because this can be confusing. Let's say you were asked to take the square root of 7 divided by 6. Well, the first thing I would do is look at my fraction. Can I reduce this fraction 7 over 6? No, 7 over 6 is a reduced fraction. I can't take the square root of 7 over 6, so let's split it. Let's make everything their own square root. So I'm going to make this the square root of 7 over the square root of 6, right? Now look at each radical. The square root of 7 is a simplified square root. The square root of 6 is a simplified square root. There's nothing I can do. We're just not allowed to leave the square root of 6 in our denominator. And guys, if anybody is saying, well, then why the hell did you rewrite it like that? If you left it like this, we didn't have a square root. Because technically this means this. So it's kind of like, yeah, we know what you're doing. You're trying to hide the square root in the denominator, but we know he's really there. So they don't even let you leave it like this because they know that this and this are equal. So you really do still have the square root of 6 in the bottom. All right. All right. So to get rid of it, we just times top and bottom by the square root of 6. We're going to try and make a perfect square. Okay. So on bottom, the front happens. The square root of 6 times the square root of 6 is the square root of 36, which is just 6. So guys, anytime you times the same two square roots together, the square root basically cancels and you're just left with the 6. All right, and then on top, the square root of 7 times the square root of 6 is going to be the square root of 7 times 6. That's the square root of 42. All right, and again, the 42 and the 6 have nothing to do with each other because this number is stuck under a square root and this one is not. All right, the only thing you have to check is if the square root of 42 can be simplified. Every now and again, the number that you create up here has to be simplified. It's a square root that can be simplified. Lucky for us, guys, no perfect squares divide evenly into 42. So that is a simplified answer. Everybody okay? Again, the division's the worst. Otherwise, the multiplying on the front, that's easy. The reducing usually, but these fractions can really throw you for a loop. All right, I'm going to do one more, and then we're going to stop. Oh, wait, what am I at? 9. All right, what if I asked you to take the square root of 1 divided by 3, 1/3, right? First, I would look at 1/3. It's a reduced fraction. I'm not getting anywhere by taking the square root of 1/3 as a whole, so let's split it. Let's rewrite this as the square root of 1 divided by the square root of 3. Well, guys, the square root of 1 is beautiful. 1's a perfect square. That's a square root that I could actually do. The square root of 1 is 1. What number did I square to get 1? It's 1. And then over the square root of 3, I can't simplify him. I can't take the square root of him. So that's your answer. We just have to fix it. We don't leave radicals in our denominator. We don't divide by an irrational number. All right, so to do that, let's times by himself, top and bottom, by square root of 3 times the square root of 3 equals. Now, guys, on top, 1 is not under a square root anymore. So you could never do 1 times this 3 because he's under a square root and 1 is not. The only thing you could ever multiply 1 with is if he had a number in front of him. Like let's say he had a 2 in front of him. You could do 1 times 2 on the outside, but I could really never multiply the root 3 with that 1 out here. So all I'm really saying is 1 times root 3 on the outside is just root 3. It's himself. Over root 3 times root 3 is the square root of 9, which is just 3. So now you are left with the square root of 3 divided by 3. And the square root of 3 is a simplified square root, so there's nothing else I can do. That's your simplified answer. Okay. Can I get a thumbs up that you're okay with that division? Like semi-okay at least. Again, the division is definitely the worst, but we are going to see that when we start solving, so I want to make sure we can handle the square root of a fraction. Okay, so guys, I created a very short homework on Delta Math. The Delta Math, though, it didn't let me put any fractions on there. So the Delta Math will only be on these kind of square roots from the front, okay? It's 10 questions. It's estimated to take you 9 minutes, so it should be pretty fast, okay? I made it due tomorrow night at 11:45. I think it's 4.4 homework number 1. Let me double check the attendance, and if nobody has any questions, I'll let you guys